Hey, my name is John Butler. I'm the Outreach Manager with Gwinnett County's Department of Water Resources. I would really call myself more of an environmental educator, specifically around water. I have a bachelor's degree in environmental health science that kind of trained me on the ecology of nature, and I focused on water. So I learned a lot about all the things that live in the water, how our water quality affects the food chain from the bottom up, and also how we affect those waterways, especially when we talk about development, the introduction of pollutants, the erosion of the stream banks, and the kind of degradation of habitat. I get to do a lot of work where I get to deal with those types of things and help people understand what we can do to improve those situations. So we're at a park here, right? All that we can see is mostly grass, but there's a big parking lot, there's roadways, there's downtown Lilburn, which has got a lot of impervious surface that doesn't allow the water to soak in and sends it all down to the creek. Yeah, so this is not a natural feature of this stream. This is some sort of a car part. I don't know, maybe it's the cover that goes over the bed of a truck or something. Nobody took that off of their vehicle and put it right there in the creek. It literally washed down this creek, probably from a dump site or something at the bridge way up by the road, and it got stuck right there. In certain areas called watersheds, all of our stuff, all of our trash, all of our yards, all of our roads, all drain to the same body of water. So you may only drop one cup every once in a while or one candy wrapper every once in a while, but you're not the only person in that watershed. And every time it rains, everybody's one piece of trash washes down into these creeks, and you see these types of problems. What's going on here is the water is coming through, again, impervious surfaces. Water doesn't soak in, big rainstorm, increased volume of water getting to the stream, more so than what's, I would say, this stream is used to. It's kind of funny. I like to talk about streams like they're alive and they have thoughts, because they move and they grow and they change and they adapt, and it just takes them a while. When we come in with development and we create those impervious surfaces, we change those flows, it changes things faster than the stream can handle. And that's what's happened here. You can see far up here on that bank that it looks very vertical. It's exposed, there's not much plant life on it. Same thing right here on this bank. Very close to vertical, very few plants of any substance that are going to be able to produce roots to hold that soil in place. So what happens is the water comes around this bend, it's all pushed up against that far bank, and it's going to start eroding that soil away. It's literally scratching the soil particles off of that bank out from underneath those trees. And you can kind of see on this side that we've got some exposed tree roots, and this is what's called undercutting. So the water is coming up with such force, it's digging out below and behind those roots. Roots need to be in the soil. Once they're exposed to the air, they change, they become less effective, the plant gets weaker, the soil keeps getting undercut, and eventually those plants will all either just die or just fall down. And you can already see this tree is falling down at some point from the other bank. We got another fallen tree here, and sometimes you'll see sections of creeks where you've just got tons of trees that have just fallen down, and all of them look like they just tilted over because they were undercut. So when we want to try and help a stream like this, or fix a stream like this, one of the first things that you want to do is you want to take a cross section of this stream. So we're talking about biodiversity and biology and things of that nature, and in order to accomplish this improved biological health, we're going to use some math, some geometry to be specific. So the short of the long for a cross section is you put a level line across this channel, you measure down how far it is from that level line to the bottom of the stream bank or the bottom of the stream itself, and you break those resulting measurements into geometric shapes. You take the area of those and you add them all together, and you get an area of this channel. And that tells you how much water this channel can hold. When you factor in how much impervious surface there is upstream, how many parking lots, how big is the parking lot, with say a 1-inch rain event, and you calculate the volume of water that would come from those parking lots into this stream, you can then kind of figure out, can it handle it? And of course this stream is showing us that it can't. So what we need to do is we need to increase that cross-sectional area. We want to actually slope these banks back so that the cross-section is bigger. Hopefully we can actually reconnect the stream to the floodplain, and that's going to allow the water to spread out and slow down. As that water's going slower, it lacks or it loses that erosive force, and it doesn't scratch away the soil from the sides of these stream banks. It just flows past them, which allows your bigger plants to come in, put down more roots, and hold those banks in place. And we can come back in through a lot of engineering, a lot of math, keeping in touch with your scientific principles, and like I said, we can help this stream. Control structure is that down that bank, how it's kind of smooth right here. You can see the stacked stone right here. So this is a really neat feature, because what's happening here is the county's come in and placed these stones in such a way that as the water comes around this bend, we're on a slight bend here, all the pressure of the water wants to go out on this, what I call the right, well not I call it, everybody calls it that, the right bank. When you're facing downstream, you got your right bank and your left bank. On the outside of that bend, the water's coming over right here. It's hitting that outside bank really hard. It has a lot of erosive force, and it's gonna dislodge a lot of the sediment that's there. It's gonna undercut the tree roots that are there and cause those trees to fall. What this structure here does is it's actually curved a little bit, and it's slightly inclined. And what that does is when that water comes around this bend, it actually kicks that water back into the center of the channel there. Keeps it away from the shoreline, from the bank, so that the trees and the plants that are there can remain kind of uninhibited and not get undercut by that force. So this is a really neat control structure here. And there's a ton, literally pages and pages of calculations that go into figuring out exactly how long that should be, how high it should be, what the inclination should be of it, how the curvature of it should be. There's a lot of calculations that go into that to be able to get that right. All right, so that was really fun to kind of walk through this area, kind of see the two dynamics. If you're interested in any way of working outdoors, working with the natural environment, the world is so dynamic out here that you end up utilizing everything that you learn in school, everything that you learn in college. At some point in time, you'll be able to apply that to your work in the environmental field. And it's an area that is kind of growing right now, and there's a ton of opportunity to work in the environmental sector, and a lot of really good opportunity to have not only a good stable career, lots of good benefits and things like that, but to also affect some positive change for the future, leave a good legacy, improve the community for those that live around these areas, so that we can have a clean environment and we can have a stable environment, and that will enhance everything from public health to economic prosperity, to people just having a better understanding of the world we live in, and that will lead to more respect for our natural environment here. So work hard, be willing to work hard, but just keep in mind that you can have a lot of fun doing a lot of different things working in the environmental field.